Hello. So today we're going to do this problem. So strictly speaking, it's asking us to let f of x be this quadratic, f of x equals 2x squared plus 3x minus 5. And the question that it's asking us is to write f of x in vertex form. I'm going to do this in two ways. One way is I'm going to calculate the vertex using the formula for calculating the vertex from the standard form. And then I'm going to solve for the coefficient a. The a, you'll see what I'm talking about when I write down what that means in a moment. And then I'm also going to do it so that's going to be our technique 1. Technique 2 is I'm going to do it by completing the square to give us more exposure to completing the square and to see another instance in which it can be used. And then we will use the vertex form to help us graph it and to help us solve for the x-intercepts. And so in other words, like the actual answer to this question will be given very quickly when we find the vertex form, but I'm going to give you some extras just so that you guys can derive more value. And well, let's begin. Okay. So we recall that a quadratic is said to be in vertex form if it can be written as f of x equals to a, x minus h squared plus k, with vertex hk. And of course the assumption here is that the constant a is non-zero. If a were 0, then this whole first part would go to 0 and we would be left with f of x equals k. And if we recall, that's a horizontal line. It's not a quadratic, right? So the a has to be non-zero. And of course I also want to make this point. Here I have x minus h, here I have h, here I have plus k, here I have k. So that sign inversion is not an accident, that's actually the way it is. Okay, that's number 1. Number 2, the vertex of a quadratic in standard form, f of x equals to ax squared plus bx plus c, is given by negative b over 2a as my x coordinate and the quadratic evaluated at that x coordinate for my y. Okay, so let's begin. So the first thing I'm going to do is I'm going to put this quadratic in vertex form by first finding the vertex. I observe that this is in standard form, you see? F of x equals to ax squared plus bx plus c. It's in standard form, so I'm going to use this formula down here to calculate the vertex. Okay. So if I look at this, I can see that my a is my 2, my b is my 3, and my c is my negative 5. So my x coordinate of my vertex, which I like to label x vertex, is equal to negative b over 2a, right? In this case, it'll be negative. Our b is positive 3, so it'll be negative 3 divided by 2 times. Our a is 2, so it'll be just 2 times 2, which will be negative 3/4. Okay? And now I'm going to calculate my y vertex. So I'm going to evaluate my function at negative 3/4. So that's going to be, I'm going to plug it in here, 2 times negative 3/4 squared plus 3 times negative 3/4 minus 5. Okay? Now observe, so now we know that we can rewrite negative 3/4 squared. By the way, I'm going to go in excruciating detail here just so that you guys can see what I'm doing, like entirely. Okay? But I don't want you guys to think that you guys have to go into this much detail when you're doing the calculations. But I just want to make sure you see everything. Okay, anyway, I'm going to shut up now. So we know that negative 3/4 squared means negative 3/4 times negative 3/4. So that's why I wrote that here. When we multiply fractions, we multiply the numerators. First of all, we know that it's negative times negative, so the result is going to be positive. I'm going to write that 2 as 2 over 1. So I can write 3 times 3 is 9. 4 times 4 is 16. Here, I can see so I have a positive 3 times a negative 3, which will mean it'll be negative, because I have a positive times a negative is negative. 3 times 3 is 9. 1 times 4 is 4. And then here, let's say negative 5 over 1 times something. This 9/4 times something. This something is going to be a number such that I'll be able to get the common denominator that will allow me to calculate in this case, this difference. So I know that 1 times 16 is going to be 16. I know that 4 times something will give me 16. What will be that number? 4. So if I multiply the bottom by 4, I multiply the top by 4. Here, 1 times what gives me 16? 16. Okay. 2 times 9 is 18. So I get 18 over 16 minus 9 times 4 is 36 over 16. Then minus 5 times 16, that'll be 80 over 16. Okay. Let me show that to you here. 16 times 5. 5 times 6 is 30. So I bring down my 0, carry my 3. 5 times 1 is 5. 5 plus 3 is 8. Okay. So that's how I know that that's 80. Okay. Now, 18 minus 36, that is going to be negative 18 over 16. Then I'm still going to have to subtract the 80 over 16. Now you might say to me, David, okay, sure, that's great and all, but how did you know that 18 minus 36 was negative 18? First of all, when I have these two integers, the 18 and the 36, I'm just looking at the numerators right now, I know that the 36 has a larger absolute value. So I know that because that one is the one that's negative, I know that the result will be negative. Then how do I know it's 18? Well, I know it's 18 because if I take 36 minus 18, I'll get 18. Okay, let me show that to you here. 36 minus 18. Okay, can I take 8 from 6? I cannot. Right, so I borrow from here. This becomes 2, this becomes 16. 16 minus 8, aha, that's 8. And then 2 minus 1 is 1. Okay, so that's how I got negative 18. Now stick with me here. Okay, now these are both negative, so they're going to add, and we're going to keep the sign. So we're going to get negative 98 over 16. This will simplify. If I divide the top and bottom by 2, I will get negative 49 over 8, and that will not simplify further. Okay, so what I have just calculated is that the vertex of this quadratic, okay, is going to be negative 3 over 4, comma, negative 49 over 8. Okay? Okay. Let's get rid of this for a moment. So what is the advantage of having gotten the vertex? Well, so we know that a quadratic in vertex form is f of x equals to a times x minus h squared plus k, where my h is my x coordinate of my vertex and where my k is my y coordinate of my vertex. Since I know that my vertex is negative 3 over 4, comma, negative 49 over 8, right? What I can do is, so this is my actual vertex here, okay, for this quadratic. I know that I can plug it into here. So what I'm going to say here is that tentatively, I'm saying tentatively because I do not know what my a is yet. Tentatively, forgive me, I'm having a brain fart at this moment. Tentatively, right? My f of x is going to equal to a x minus this negative 3/4 squared plus negative, so it'll be minus 49 over 8. And let me just rewrite that one more time here. F of x equals to a x plus 3 over 4 squared minus 49 over 8. Okay. So now what we need to do is we need to find the a. Okay. So one of the things that I like to do when I'm finding the a here is one of the things we have to do is we have to find another point of the quadratic of this quadratic that we can use to plug into this quadratic to find the a. And what I like to do a lot is, if the vertex does not go through the y-axis, then I can pick a point on the y-axis to as my second point. Okay. So, for example, I know that every point on the y-axis has x coordinate 0. And if you notice, well, if I do use x equals 0, then this term will go to 0, this term will go to 0, and we're left with the point 0 comma negative 5. In other words, we found the y-intercept. And that's why if the quadratic does not have its vertex on the y-axis, I like to use the y-intercept because it's easy to calculate. If you set x equals 0, you just saw right there how quick it was. Right? So here, so find a, we need another point on the quadratic and I guess we could memorialize it as follows. We could say that David's tip if so basically my tip here is that if the vertex of the quadratic does not lie on the y-axis, then find the y-intercept to use as the second point. The second point we need to calculate for my a. And in other words, i.e. we set x equal to 0 and solve for y. We already saw that if we set x equals 0 here, okay, let me just write this down here. F of 0 is going to equal to 2 times 0 squared plus 3 times 0 minus 5 implies that the point 0 comma 5 0 comma negative 5 is on the parabola. Okay, so now let's take this information to find my a. Okay, what I'm going to do is I'm going to erase this. Okay, this we're going to erase this as well now. Okay, so what we have just determined, well, first of all, what does it mean that this point is on the graph? It means that it must make the equation of the quadratic true. And that is true whether the equation of the quadratic is in standard form or if the equation of the quadratic is in vertex form. So in this particular case, we're going to set our y value, negative 5, equal to this function evaluated at x equals 0. In other words, it's going to be a times 0 plus 3/4 squared minus 49 over 8. Okay? What I'm going to do is I'm going to add this 49 over 8 to the other side, plus 49 over 8 plus 49 over 8. Okay? Then, now this part, I know that 0 plus 3/4 is just 3/4. So I can simply rewrite this as a times 3 over 4 squared equals to whatever this is. Now I'm going to calculate that over here. Let me get some room for us over here. Okay, I'm going to get rid of this right now. So let me just summarize here. The vertex is negative 3/4 comma negative 49 over 8. I can get rid of this. Okay, so now I'm going to calculate this here. Negative 5 plus 49 over 8 is the same thing as negative 5 over 1 times something, right? Some fraction that's going to equal 1 that's going to allow us to make the two fractions have the same common denominator, plus 49 over 8. And I want to ask what times 1 will give me 8. Aha, it'll be 8. So 8 on the top and bottom. Negative 5 times 8 will be negative 40 over 8 plus 49 over 8. Now if I have negative 40 and I add 49, that's going to be positive 9 over 8. So I can see that this is going to be 9 over 8. Okay, let me get rid of this. Okay. Now, we know what 3 over 4 squared is. 3 over 4 squared, what does squaring mean? It means we multiply a number with itself. So 3 over 4 squared is going to be 3/4 times 3/4, which is going to give us 3 times 3 is 9 over 4 times 4 is 16. And again, we recall that that follows because whenever we multiply fractions, the product of two fractions is the fraction whose numerator is the product of the numerators and whose denominator is the product of the denominators. Okay? So I can rewrite this as 9 over 8 equals a times 9 over 16. Okay? And how do I isolate the a? Well, I could say that I divide by 9 over 16 on the right and I divide by 9 over 16 on the left. But I could also say it as multiply by the reciprocal of 9 over 16. Because whenever we divide by a fraction, that's the same as multiplying by the reciprocal. Okay? So if I do that on the right, I have to do that on the left. Now if you notice, here, we're left with just a. So let me put a little arrow here. I'm gonna write this equation here. 16, this 9 and this 9 go away. 16 divided by 8 is 2. So I'm left with 2 here. This 9 over 16 times 16 over 9, that's just going to be 1. So it's going to be just 1 times a, which will give us a. So therefore we have found our a to be 2. Okay? So now finally, we're in a position to state what the vertex form is. See? The only thing that was left for us to get the vertex form was to find out what the a was. We just found that the a was 2. So my vertex form of this quadratic is f of x equals 2 times x plus 3 over 4 squared minus 49 over 8. Okay? Okay. And there we go. If we wanted to, we could stop right here. We have answered the question as stated. Hello again. So now we're going to use technique 2, completing the square, to convert this quadratic into vertex form. Let's begin by copying it over here. Okay, so f of x is equal to 2x squared plus 3x minus 5. The first thing that we're going to have to do is we're going to have to make this quadratic, which is in standard form, look more like this one, which is x squared plus 2ax plus a squared, in the sense that I want to make the leading coefficient 1. Okay? So here, what I'm going to do is I'm going to factor out a 2 from the expression on the right. This is going to be 2 times x squared plus 3 over 2x minus 5 over 2. Why is that the case? Because 2 times x squared will be 2x squared. 2 times 3 over 2x will be 3x. 2 times negative 5 over 2 will be negative 5. Okay? Now, one of the things I want you guys to realize, and as we do this more and more together, to completing the square, is I want you to realize that it's basically just the replacement of one algebraic expression with another algebraic expression that is equal, okay, to that algebraic expression. Now here, we have here our expression x plus a squared equals to x squared plus 2ax plus a squared. And we recall that basically our goal, whenever we're doing completing the square, is we want to match the x squared plus 2ax with the x squared plus 3/2 x. Because when we match those, we can fix the rest of it. Okay? Okay, so let's look over here. The only way that x squared plus 3/2 x is going to match x squared plus 2ax is if somehow 2ax, if 2a is equal to 3/2. Okay? And I can make that happen by solving this equation. I divide by 2, I divide it by 2. This becomes a equals to 3/2 divided by 2/1, which becomes, whenever we divide by a fraction, we multiply by the reciprocal. So this becomes 3/2 times 1/2, which becomes 3/4. Okay? So let me summarize that over here. So a equals to 3/4. Okay? So let's get rid of this and just summarize by writing that a equals to 3/4. Now what we're going to do is we're going to plug this in to our equation on the right hand side. X plus 3/4 squared equals to x squared plus 3/2x. We know that because we solved this a on the condition that it gave us the 3/2 x. So we know that it's plus 3/2 x, and then finally it is plus 9/16, because the 9/16 is precisely the a squared, the 3/4 squared. What does it mean to square a number? It means you multiply that number with itself. So 3/4 squared means 3/4 times 3/4. What's the product of two fractions? It's the fraction whose numerator is the product of the numerators of the fractions being multiplied, and whose denominator is the product of the denominators of the fractions being multiplied. In this case, 3 times 3 would be 9, 4 times 4 would be 16, and so that's why 3/4 squared is 9/16. But we're where we want to be now, because look at this. I know that I can solve now for this expression if I subtract the 9/16 to the other side. So minus 9/16 minus 9/16, and we get x plus 3/4 squared minus 9/16 is equal to x squared plus 3/2 x. So now we take that side work that we've done on the side and we bring that over to this part here. So I can now rewrite this expression as 2 times x plus 3/4 squared minus 9/16 minus 5/2. Sorry about that. Minus 5/2. Then we close our parentheses. This was replaced with this. And this expression came from this identity, right? When we found the a that made 2a that made the first two terms match, we were able to find this identity, okay? And again, as I've mentioned to you before, you can always calculate that identity from first principles. You can just take x plus a times x plus a, distribute it, and then you get this equation, this identity. So you don't even have to memorize that. Okay? But anyway, let's continue now with this part. So now this becomes 2 times x plus 3/4 squared minus 9/16 minus 5/2 times something, right? Why times something? Because in order to combine these two fractions, we're going to need to have them with the same denominator. Yes. Now I ask myself, can I multiply 2 by something to get 16? And if you think about it for a few moments, you will see that indeed we can. We can multiply by 8. Okay? 8 times 2 is 16. 8 times 5 is 40. So I can see that this is going to simplify to 2, open bracket, x plus 3 over 4 squared minus 9 over 16 minus 40 over 16. Now you can see that's going to become negative 49 over 16. So it's going to be 2, open brackets, x plus 3 over 4 squared minus 49 over 16, like this. Then finally, when we're in this form, we can distribute our 2 inside. So it becomes 2, x plus 3 over 4 squared minus, now if I multiply the 2 times 49, I'm going to get 96 on the top. So I'm going to have 96 over, I'm sorry. If I multiply the 2 times this fraction, I'm going to get 98 over 16. And when I divide the top and bottom by 2, I'll get 49 over 8. So now what I want you all to observe is that we were able to get the vertex form here, which is identical to the vertex form we got originally, but in this case we used completing the squares to condense this into a square. Okay. And now let's just take a few moments just to graph this, okay? And yes. So now we're gonna graph it, and again we already answered the question from the first go when we got the vertex form. We had already answered the question, but we're doing this to continue training ourselves to know what we're doing with respect to quadratic, to take it as another opportunity to see a quadratic graph, to take it as another opportunity of going through these motions to build up these basic techniques, right? Okay. Okay, so we already got the vertex, right? So we know that the axis of symmetry is always the vertical line that goes through the x-coordinate of the vertex. So in this case, how do we write a vertical line? We write a vertical line as x equals some constant, where that constant is the x value that we want to go through. In this case, x equals negative 3 over 4. Okay? That's number 1. Number 2, we need to find out the domain. We know that for all quadratics, the domain will always be negative infinity to infinity. Okay? What about the range? Okay? Now, we know that the range is basically the set of all y values achieved by a function. In this case, we have a quadratic. Any quadratic, or in general, any polynomial with an even degree, will not have a range that is from negative infinity to infinity. Okay, so we have to find out what it is. In this case, we see that because the a is positive, it will open up, right? So if we want to think about it as our cartoon before we actually do the real graph, it's going to open up like this. And we know that the vertex y-coordinate is always the minimum value achieved when it opens up, or if it had opened down, it would have been the maximum value achieved. In this case, this value will be negative 49 over 8, and so the range will be from negative 49 over 8 to infinity. So let me write that in here. I use a square bracket to denote the fact that I actually achieve that value. Okay? Okay? And then, let me see what else we're going to do here. Oh yes, so now we want to find out our x-intercepts, right? We always want to know our x-intercepts when we're graphing, unless there are no x-intercepts. But now let me show you something cool about what we've done. Because we already have gotten the quadratic in vertex form, I can actually solve for the x-intercepts in a very simple way. Okay, So let me actually, and let me notate what I'm missing here. I'm missing the x-intercepts. I'm sorry that I'm getting this all like overblown and stuff, but I hope you'll bear with me. So to find the x-intercepts, right, we recall that to find the x-intercepts, we set y equal to 0 and solve for x. Now, I could set this equal to 0, and then we could try to factor it, we could try to complete the square, we could try to use the quadratic formula. But since we already got the vertex form, we actually already have done the completing the square. So I'm going to take my vertex form and I'm going to set it equal to 0 because 0 equals this, okay? Because I'm going to set the y equal to 0. So now I have this. I add the 49/8 to the other side, okay? I get 49/8 equals to 2 times x plus 3/4 squared. My goal, again, whenever we have it like in vertex form like this and I'm trying to find the x-intercept, my goal is to get this square term by itself so I can then square root, right? Here, you might say, oh, can we square root already? We can't because there's this 2 in front. So we have to divide out by the 2 first, like this. Now, 49/8 divided by the number 2 is the same thing as 49/8, the fraction, divided by the fraction 2/1. Because remember, we don't know how to divide a fraction by a whole number. But we do know how to divide a fraction by a fraction, and we do know how to write a whole number as a fraction, which is what we've done there. Now, whenever we divide by a fraction, we multiply by the reciprocal. So this is going to become 49/8 times the reciprocal of 2/1, which is 1/2. And when I multiply those fractions, 49 times 1 will be 49. 8 times 2 will be 16. So I can see that 49/16 will equal to x plus 3/4 squared. Oh my god, I can't believe this. As I recall writing this problem, I thought that I got this problem like with just random numbers, but it looks like it's going to come out super nice. So let's do this together. So now I'm going to take the square root of both sides. When I take the square root of the left-hand side, I'm going to affix the plus minus because I know that if I take the positive square root or if I take the negative square root, when I square it, I'm going to get the positive 49/16. That's going to equal to my x plus 3/4. Now the plus minus square root of 49/16 will be plus minus 7/4. And that's going to equal to my x plus my 3/4. I'm now going to subtract my 3/4. Okay, I'm going to subtract my 3/4. Okay, and this is gonna go away. Okay, and so I'm going to be left with negative 3/4 plus minus 7/4, and that's going to equal to my x. So now I'm gonna simplify this over here a little bit here. So, well, actually, yes. So for example, if I take negative 3/4 plus 7/4, so x equals to negative 3/4 plus 7/4, or x equals negative 3/4 minus 7/4. See, x is going to be negative 3/4 plus 7/4, which is there, or negative 3/4 minus 7/4. Now, if it's negative 3/4 plus 7/4, that's going to be positive 4/4, which is just 1. And if it's negative 3/4 minus 7/4, that's negative 10/4. And that'll simplify when I divide the top and bottom by 2 to negative 5/2. So now let's summarize that here. What are my x-intercepts? My x-intercepts are 1, 0, and negative 5/2, 0. Okay? Okay. Now we're going to try to find the y-intercepts. Now to find the y-intercepts, we set x equals 0 and solve for y. So in this case, since I have the standard form, this will make it very easy for us to calculate the y-intercept. I can calculate, in other words, f at 0, which gives me 2 times 0 squared plus 3 times 0 minus 5. Now, 0 squared is 0 times 0 times 2 is still 0. So that's 0. 3 times 0, that's 0. So I have 0 plus 0 minus 5. That's 0 minus 5. That's minus 5. Or in other words, negative 5. What does that tell us? So that tells us that the point 0, negative 5 is on the graph. Or in other words, that's our y-intercept. Okay? And now we're in position to draw the graph. So, as always, one of the things I want to do before I actually draw my graph paper is I want to figure out what points I really need. I know that my x-intercepts are at 1 and negative 5/2. I know that negative 5/2 it's actually 2.5, so I need negative 2.5 over there, 1 over here. I need to go down negative 5 on the y-axis. This is my vertex, negative 3/4, so negative 0.75, and it's going to be down about 6. We know that 8 times 6 is 48, so this is just a little under 6. In fact, we can actually calculate that using long division here, right? So that's 8 1/8, I think. 6 1/8. But let's look at that together. 8 goes into 49. 8 times 6 is 48. So 6 times 8, 48. I'm left with 49 minus 48. That's 1. So it's 6 1/8, right? And if I wanted to get a decimal expansion, I could do that here. But for us, for our graph, we know that we're going to go just a little bit below the 6 because it's negative 49 over 8. Okay, so let's do that together. So let's graph that. With this in mind, we're now ready to graph this. Okay. And we know that because the A is positive, it opens upward. Okay, so. This is my 1. That's my 2, 3, negative 1, negative 2, negative 3. 1, 2, 3, 4, 5, 6. Okay, this is negative 5. This is negative 6. And then, let's say, negative 7. Now you might say, well, David, why are you drawing it like so blown up? And the reason why I'm drawing it super blown up is because I want to, you're going to see right now. I want to put enough tick marks in here. So 1, 2, 3, 4, 5, 6, 7 tick marks. So now I've broken it up into 8s because if you count it, you'll have 1, 2, 3, 4, 5, 6, 7, 8 pieces. And then here, negative 5/2, 2, 4, and then that's 5/2 right there. And then negative 5, and then let me see here, negative 3/4. So if I slice this into quarters, 1, 2, 3. Okay. So now I can plot my points in a very accurate manner. Okay. Let me see here. First, in red, let me draw in my axis of symmetry, which is the vertical line through x equals 3/4. And we know that that vertical line is our axis of symmetry. We know that it goes all the way down to negative 49/8, which we just saw as negative 6 1/8, which means it's going to be right here. Let me see here. Like about right there. Okay. We know that the y-intercept is at 0, -5. So if I went 3/4 to go here, I need to go 3/4 this way to find another point with y value 5. With y value -5. So let me see here. I'm going to break this into quarters. 1, 2, 3/4. So 1, 2, 3. 1, 2, 3. So I go down here. Let's see. Like about right there. Now I can put my x-intercepts 1, 0. So 1 right here. And -5/2, 0. So -2.5. So right there. Right? Okay. And now all I have to do is connect these points together. One of the things I want to show you when I do this is how I can really show that I know what I'm doing. Okay, and I want you guys to be able to do the same. So the only part that is probably gonna be bad about this is just that this graph is not gonna look like completely like perfectly smooth and perfect, but I'm trying my best. Okay. So that's my graph. And in fact, let's go through this a little more. This point, how did I get it? Well, I knew that I had to go 3/4 to go from the axis of symmetry to here, so I would have to go 3/4 this way. And if I count that out, 1, 2, 3, 4, 5, 6/4. 6/4 is 3/2. So I claim that this point is -3/2, comma, -5. I claim that point is on this parabola. This, of course, is my vertex, which of course is the -3/4, comma, -49/8, or in other words, -6 1/8. This is my y-intercepts, -5/2, 0, 1, 0, my y-coordinate. And of course, if I wanted to, I could plug this in here to see if it indeed gave us the result. Let's do that here real briefly. F of -3/2 is equal to 2 times -3/2 squared plus 3 times -3/2 minus 5. This is going to be -3/2 squared is -3/2 times -3/2, which will be +9/4. So 2 times 9/4 minus 9/4 minus 5. Right, because why is this minus 9/4? Because 3 times 3 is 9, but it's a positive times a negative, so it's minus, and then, minus over 2, because here there's the denominator of the 3 would be 1, 1 times 2 is 2. So then this is going to become, this 2 times 9/4 will make this into a 9/2. 9/2 minus 9/2 minus 5. You can see 9/2 minus 9/2 is 0. 0 minus 5 is the -5. So we have just verified that this point actually is on the graph, although originally when we got it, we were just using the property of the symmetry of the axis of symmetry, and that's what makes the axis of symmetry so important, right? Okay. And let me see what else, and that's basically it for us for this problem. I hope that you all have enjoyed this explanation, and I look forward to seeing you again soon, and thank you so much.